Everyone, Mrs. Moore here with you today to review the answers to your Chapter 1 assessment. I'm going to begin here with the first block of questions from Lesson 1.1. So you can flip to that part in your workbook maybe to help you fill in these questions, or you can use your notebook, and maybe this place value chart would be of use to you when you're exploring the different positions and place values, okay? So I'm just going to go ahead and fill in the part that we did together here in the classroom, and then we can use that to help our understanding for the rest of the chart, okay? So we're looking at this number right up here. Let me see if I can get it a different color for you. Right here, 380,215,674 to answer the questions that are in this chart, okay? And what we could see is that we are looking at the 5-digit first and considering where is this 5 located inside of the big number. So we can see it sitting right here in this spot. So what spot is that? What place is that? That will help us decide on the value of that number, of that digit. So I know the decimal point lives right there at the back of the ones position. I'm going to use my place value chart and say ones, tens, hundreds, thousands until I get to this spot. So if this were the thousand spot, then I know a 5 sitting in the thousand spot is worth 5,000. So the value of the 5 in this large number is 5,000. The name of the position, the name, so I'm looking for a word, the name of the position where that 5 is sitting is thousands. The name of the place value that's 10 times larger would be 10,000. Remember, every time we take one hop to the left, that place value is 10 times bigger. And every time we take one hop to the right, that place value is 10 times smaller. So these two columns were to help toggle between the different place values. So 10 times bigger than thousands would be 10 thousands, and 10 times smaller than thousands would be the hundreds position. So we're going to go through and do a couple here with that same technique. So let's look next at the number 7. Can you see the number 7 in this number? Yep, I see it right over here. What position is that? That's just the tens position, right? So a 7 in the tens position is just worth 70. What position is 10 times bigger? What's the name of that place value that's 10 times bigger? That's going to be the hundreds position. And what's the name of the place value that's 10 times smaller? That's just the ones position. All right, I'm going to do one more here. Check out the next one. Where is the 8? Where is the 8? So I'm looking through. Oh my goodness, it's all the way down here. So that 8 is sitting quite a far way away from the decimal point. So I'm going to count how many positions I need to fill up to get to that spot. I've got ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions. So an 8 sitting in the 10 million spot is worth 80 million. So the 10 million spot. What place is 10 times bigger than that? That's going to be the 100 million spot. And what place value would be 10 times smaller than that? It'd just be the millions or the 1 million spot. Okay, so I'll let you finish those last two on your own if you needed some support with them. I'm going to encourage you to use that place value chart. The next bank of questions deals with maybe translating or rewriting numbers in different formats. We talked about in school how numbers can be thought of like elements or chemicals that, for water, for instance, takes on different forms. It could be solid, it could be liquid, it could be in a gas form, but all together, they're still the same thing. Now, numbers have different forms. We could write them in standard form, which is the number form of it. We could write them in word form, which you'll see here on the paper. We could write them in super expanded form. So there's different kind of formats to showcase the same realities about numbers. So let's try number 6 here. We want to write the number in standard form, and it looks like we're given it as a number name, so it's all stretched out in words. So we've got, let's preview this, 36 billion, oh boy, this is going to be a big one, 415 million, 4,920. So that's a lot going on, right? We've got a lot of digits at work, and we've got some place values to help guide our position here. We've got billions involved. We've got millions. We've got some thousands. We've got some hundreds. And then our 20 we know is going to land in that first units period. All right. Remember what we did in class? We would start with the period, and then we would build place value slots where we needed to fill digits in. We need to know how many slots to make. And for that, we're going to go all the way to the front and find out how big our number is going to be. It's going to be all the way in, it looks like the billions period. So to build the number 36 billion, I'm going to need 2 digits, right? One for the 30 part and one for the 6. So I need 2 digits in the billions period. So let's go all the way backwards to the 10 billions period. Ready? Ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions. Okay, let me just make sure I did that right. I'm going to use commas to help divide up my periods a little bit better. Okay, so we've got the units or the ones period, the thousands period, the millions period, and then 2 digits into the billions. That's what I needed. Now we can just go start plugging those numbers in, plugging those digits in. So 36 belongs in the billions period. There's 36. And 415 belongs in the millions period. So how do I write 415? Just like it sounds, 415. And then I go on to the 4,000s period. Okay, so only 4 in the thousands. So I didn't hear anything about these positions. So what am I going to put in those positions that I wasn't given any information about? Placeholder zeros. That fills up those positions so that the 4 can be in the place it belongs. 4,000. And then the last one, we've got 920. Okay, so 9 goes here. That's in the 100 spot. And then 20 fills up the rest of those positions. There it is. That's a big number. And we just translated it into standard form. Number 7, you're doing the opposite. I'm giving you a big number and you're translating it into the number named word form. So let's look back at how we do that. We kind of look at each period and say their name and their position as we go along. So let's start with this first bank of numbers. Say what you see. I see a 670, and then we say what place value it's in. What place value is the 670 in? It's in the millions period. So we're going to say 670 million. Okay. And then go to the next group. That's 200,000. And then what do you see in the last period here? Just 50. Good job. So moving on to lesson 1.2. Let me scroll my screen down a little bit. Moving on to lesson 1.2, we did a lot of work here with stretching a number out in different notations. We talked about something called easy expanded, where we only looked at the values or the worth of each digit. And then we looked at super expanded, where we took it into this more grown up notation and stretched it into digits and positions. So here's the number that we're using to demonstrate both easy and super expanded forms. So we go from digit to digit and call out their values. So what is the value of this 8 right here? The 8 is in the 10,000 spot. So it's worth 80,000. Plus, now look at the 2. What is the 2 worth? It's sitting in the 1,000 spot, so it's worth 2,000. Plus, what's that 5 worth? It's sitting in the 100 spot, so it's worth 500. Nothing to say about that 0. It doesn't have any value, so we just move on. And where's the 3 sitting? It's in the 1s position, so we just put a 3. Now, if we take it apart just a little bit further, and we talk about not only what digit is involved, but what position it's in, that's how you do super expanded. You take the digit and you put the position that it's sitting in. You take the digit and what position it's in. You take the digit and what position it's in. If you need any more help with that, we did a lot of work in our workbook from lesson 1.2. All right, I think you guys had a really fun time with lesson 1.3. On the test, I saw an overwhelming mastery of this section. You did a good job of either scooting these digits backward if it was division, or moving those digits forward if it were multiplication, because division by powers of 10 makes a number smaller by this many positions. And multiplying times the power of 10 makes a number bigger by that many positions. So we either are taking zeros off or we're adding zeros on, depending on the exponent involved. So remember, the exponent is that little number next to the power of 10, and that tells you how many positions to shove the digits of your expression. So I'm picking up the 8, the 2, the 5, the 0, the 0, the 0, the 0, and the 0, and moving them 3 positions backward on our place value chart, which makes it look like those 3 zeros disappear. What's really happening is they're sneaking behind the decimal point, and we don't really write them anymore because they don't carry any value once they slip past that decimal point. So if you're looking at the multiplication side of it, it's like we're picking up the 3, the 7, and the 4, and we're moving it 4 positions that way. So we pick them up, and all the spaces that are now empty have to be filled up with something, so we fill them up with zeros. I think I talked to you about this metaphor of Thomas the Train Set, where your 3, your 7, and your 4, you have to pretend that they are all connected pieces of a long train, right? And when you move, the 3, the 7, and the 4 come with it. So they'll just slide over down the place values, okay? So just going quickly through the rest of them, division makes it smaller, so we're going to pull back 1 place value, and that changes it to 2,500. This one, multiplication, makes it bigger by 6 positions. So we're going to add on 1, 2, 3, 4, 5, 6 placeholder zeros. Wow, 1 billion. That's a huge number. And then we're going to make this one bigger by 2 positions. That's how it's done. sneaking down to this section, we had some fun, not only in our own classroom, but then recently with third graders, getting comfortable with the different properties. So you could use that cut and sort activity that we did. You can use your anchor chart that's in your math notebook to help remind you of the different properties and their tendencies. So if I'm looking at this first one, I see that a heart times a smiley is equal to a smiley times a heart. So what changed? The ordering changed. So if the ordering changed, I know that that relates to commutative property, because it doesn't matter if I have, you know, going from home to school or school to home, it's still the same distance. And that's what commutative property showcases. So I'm going to connect this one down here to commutative property. And we talked a little bit about how if a number is there to start and you see the same number to finish, you're seeing its identity. It's like looking in a mirror, right? So when we have a term of 0 being added to any number, we see its identity. Now this one here reminds me of that math theater production we did with the kids getting together for a group project, right? And we found out that it didn't matter which friends got together first, as long as additions involved or multiplications involved, then you're going to get the same result in the end. So let's say, you know, here Jen and Mike got together first, and then they got together with Colin. But over here, Colin and Mike got together first, and then they got together with Jen. But all in all, they still are all together in the end. They associate with each other. The groupings have changed. So the groupings changed here, and that's associative property. Now this guy over here, we are getting comfortable with a number passing itself out to different terms. I gave you a little secret tip that anytime that you see both multiplication and addition together in an equation, then that's a key that this is probably distributive property, because distribute, remember, means to pass out or collect. Collect would be the opposite. So pass out or collect a common term. And so that guy's going to go all the way up here. And this last one, let's check it out. Anything multiplied times 0 is going to result in 0, and that's probably the easiest property to identify. That's the 0 property of multiplication. Right, not bad. We're getting through this. Front-end estimation. So I would say that estimation is a skill that is supposed to support your overall reasoning. So these two techniques are just two different strategies that we've studied. Now remember, front-end estimation looks only at what? The front number. We did this in class where I asked you to please put a box around each of the front numbers to focus yourself on only the front numbers. Everybody else changes to zeros. So I'm just going to rewrite these numbers with only attention to the front number. Everybody else changes to 0, no matter what they are. That's all. Now we combine. That's pretty easy, isn't it? Now, front-end estimation, while it can be easy and quick, it's not as accurate. It's not as reliable. So just be careful when you're estimating. If you need something that's easy and quick, but don't really mind if it's not super reliable, then front-end estimation is going to be your friend. On the other hand, a different estimation technique that we've studied is called rounding. So rounding takes into account value that happens in different parts of the number. Remember, when you're not told what position to round to, you're supposed to round to the greatest place value of the smallest number. So let's go find the smallest number. Looks like this right here, 343. And the greatest place value is the hundreds position. So for the entire problem, we're going to round to the hundreds position. You find the greatest place value of the smallest number. So here we go. We're going to round by looking at the guy next door to help us decide on its final value. Does the 4 have the power to change that digit of 3? No, it doesn't, because it's 4 or less. You let it go, you let it rest. So that one just stays at 300. Look next door to the 6. You've got an 8. 8 for sure is bigger. 8 has the power to change that 6 to a 7. 5 or more, you guys always say, let it soar. The next one over here, we're checking out the digit next door, and we find that 2 does not have enough power to change the 7. Now, you might be asking yourself, what about the 3? The 3 isn't involved at all in the rounding. We just transfer it over because it wasn't part of the rounding place value. It just gets left alone. All right, last one. 0 doesn't have enough power to change 0. We leave the 1 where it was in the position. And now we're ready to combine. Zeros, zeros, 7, 7, and 3. Here's your doubles, 14, 15, 16, 17. That's 17, carry the 1, 1 and 3 and 1, that's 5. So 5,700 is gonna be it. Last 2 problems. Now we're on to actual adding and subtracting, right? So this involves aligning up the place values. We have some lined paper on the back of your test that I was hoping you would use to assist you in this process. I'm looking for the largest number to position on top because I know addition's commutative. It doesn't matter which one I put on top. The biggest one, though, will help me organize the spacing a little bit better. So I'm going to try here without lines. I'm going to write very neatly 3,829 plus 1,760 plus 704 plus 322. So I want you to first check that your setup is correct, that your 9, your 0, your 4, your 2 are all stacked on top of each other. Remember, because the decimal points live right next door here, and we always want our decimal points what? Aligned. Now we can go after the actual adding part. 9 and 4 and 2 makes 9 plus 4 plus 2. That's 15. Carry the 1. Then 1 and 2 and 6 and 0 and 2. That makes 11. And then 1 and 8 and 7 and 7 and 3. That makes 26. And then 2 and 3 and 1. That makes 6. So our final answer here is 6,615. I'm going to kind of get rid of this so that I have a little space to show you the other one. All right. Now the last one, we've got some subtraction here. So we might run into some regrouping or borrowing, as you might call it. But I'm going to stretch this out really evenly so that it is useful for me for regrouping. And then I've got to position the 28,000 in the right spot. Maybe you work backwards and you fill in that number from the ones position so that you get everybody in the place that they belong, right? Does it look clean? Looks ready to go? Let's go for it. I can't do 1 take away from 0. So I have to go find some value. No value here for me. No value here. Oh, here's some value. I'm going to strike down this digit by 1 and move the value over to the guy next door so that this digit now has a value of 10, but I need the value all the way down here. So I need to strike him down to 9. Pull it over again. There's 10. Nope, I need it next door. So now you're a 9. Pull it down one more time. Now I can perform the subtraction. 10 minus 1, 9. 9 minus 8, 1. 9 minus 7, 2. Wait, 9 minus, this was supposed to be a 2, I think. 9 minus, do I have something wrong on my paper? Let's see. Stepping back a second, taking a look. I think I might have transferred the wrong number. Mrs. Moore, you transferred the wrong number. I'm glad I caught that mistake. Start again. Just a little commercial break here for you. Let me write that number again. 746,000, only 500. I only need 2 zeros on the back. And then work backwards, get that digits in the right position. Very good. All right, same routine. I'm going to have to go and regroup in order to make this happen. So let's go grab some value from that 5. Pull it down the line. Pull it down the line. Now I can perform the subtraction. That's a 9. That's a 1. I can't take 7 from 4, so let me go get some value from this guy here. Change it to a 14. 14 minus 7. Oh, I can't subtract here either. Oh my goodness. So I have to go and grab some value from here. Now it's 15 minus 8. That's 7. 3 minus 2. 7 minus nothing. That looks a little better. So regrouping is a difficult skill, especially when you have multiple digits that you have to drag that value in between. But use the lined paper to help you organize it. Maybe if I would have used it, I would have seen my mistake a little earlier. But all in all, I hope this video helps. And if your notebook can't answer the rest of your questions, come see me anytime before school.